In this video, we are going to continue with the rocker assembly. At this point, we've created part files for all 6 of the parts of the overall rocker assembly component. We created the web plate, drive link, center link, rocker link, peg 10, and peg 15. Now we are going to bring them all together into an assembly file. So this is brand new stuff for you guys. So we're going to go to File, New, and we've done part, we've done drawing, but what did we skip over? Assembly. We are now going to create assembly files. So we're going to do standard IAM, a standard assembly, inventor assembly, that's the IAM. And you'll notice that, the ribbon looks a little similar to the part file. You have your gray workspace over here, but things are a little bit different. You won't find your start new sketch, things like that, because you're not creating new parts here. What you are doing within an assembly is you are bringing in 2 or more parts, and then you are telling them how they need to interact with one another. So the first thing you're going to have to do is bring the parts in that you want to connect. Like imagine we're playing with blocks today. We're going to bring in the different blocks, and then we're going to put them where we want them. And then we're going to use, glue or bolts or however you want to constrain it to have the overall finished product look and move and interact in the way that it would in the real world. So first you're going to have to place from Content Center. Well, you want to do place. So the place is where you insert different things, whether it be a part or something else. We'll talk about that later. So I'm going to hit the little drop down, and then you can do place from Content Center, and these are the 2 that we're going to be working with in this course. If you are this is important, so listen up. If you are importing a file, a part file, you will do place. If you are inserting things like a bolt or a screw, you're going to do place from Content Center. Think of Content Center as like Inventor's library of all the pre-made parts that they have. Like you don't need to draw a screw. Like screws are pretty standard. You can insert a screw that they've already created and put in the Content Center. So because in this one we're doing straight parts that we've created, we're going to go to place. And you're going to insert it. So you have to find where you saved it. And you can do them one at a time. I'm going to hit Shift and then hit the bottom one. And this will let me place them. So you can see all 6 parts that I've created. And when I click, it's going to let me put as many as I want. But I really only want 1 of all of these. And I do actually want 2 of each of the pegs. So I'm going to go ahead and do place again. And I'm going to hit Shift to get both of them and do both of these. So I have 1, 2, 3, 4, 5, 6, 7, 8 parts that I totally want. And now, right now, these 8 parts are floating in the abyss. There is nothing that they can't do. I can move them. I can even have them move through each other. There's no physics being applied at all. So now we are going to apply the physics. So the way we apply physics is by doing this button over here called Constraint. And what Constraint does is it limits the degrees of freedom that the parts are able to move. Like think of your your body and your joints. You are free to move within certain degrees of freedom. Like my knee can't bend sideways and it can only bend in one direction. That's because the other degrees of freedom are limited or constrained. That's what we're going to be doing right now. Like your shoulder has a lot more range of motion. There's more degrees of freedom that your shoulder is able to move. So the first thing before we do that is you want to have one piece be like your base. And you want everything else to move around that base. So you're going to have to choose a part that you want to not move at all. And then you want everything to move relative to it. So you can't forget this step or else it's going to mess you up. So I'm going to choose the web plate to be the one that I don't want to move. And when you get in trouble with your parents and your parents don't want you to leave or go out, what happens? You get grounded. And that's what we're going to do to this part. We're going to say you're grounded and you can't move and you have to stay in this spot until I say so. So you're going to right click and hit grounded. Now, watch what happens. I'm clicking and hold, it won't move. I can't get it to move. Everyone else can move. Click, hold, move. This one, I can't do it. So it's grounded. I'm going to change my home view. Let's choose one where that's a little bit nicer looking. So that would be, I'm always really bad at. Yeah, I like this. I'm going to make this my home view. So I'm going to right click and then set current view as home. Good. I think I made a mistake. No, I didn't. Never mind. Sorry. Okay. So now let's look at the rocker assembly and look at how it connects. We have a peg right here, and that connects to the drive link. Peg connecting the center link. Peg, rocker link, peg back to the web plate. So in here is going to be inserted the peg 15, because this is a height of 10, and this is a height of 5, and this is a height of 5, and this is a height of 5. So the peg 15s are going to be going into the web plate, and you imagine that this is 15 and this is 10, 5 would be sticking out, and then that 5 that's sticking out is what gets inserted into. And then when these are connected, or whichever two they are, it's 5 and 5, which is why the pegs are 10 for these ones. So here's how you do it. This is a really important step. You're going to hit constrain. Okay. So what am I looking at here, Mr. Cooperman? I have no idea. Okay. When you are constraining it, you have different ways that you're able to limit the degrees of freedom. You can do mate, angle, tangent, insert, symmetry. These are all different types of constraints that you're applying. And we've done constraints, geometric constraints, when we created our parts. It's kind of similar to that. Like you are limited in how you are able to move. What a mate constraint does is a mate constraint will mate two surfaces together, but it's able to slide along it. Let's just try it just to show you. I'm going to hit mate, and I'm going to say this surface and this surface are now mated. It makes a cool little noise. I'm going to hit OK. Now, I could move this, but I can't move it. Let me give you a different view. I can move this, but you can see that those two surfaces that I mated have to be touching each other. Even though that looks like it's going higher, it's really just going a lot further away. Because if you look at it from this view, I can't move it up or down. It's mated. It has to be stuck on that plane. And if I ever want to delete a constraint, you can click it and watch what happens when I click it. It appears over here. You can do that little drop down, and here's that mate constraint. We can right click and delete it. And now I'm free to move it about again. The angle constraint will kind of be like the mate, only it'll specify at a different angle other than 0 degrees. Tangent will make it tangent, and symmetry, I don't really use symmetry that often. But here's the big one that we're going to be using, and we're going to almost always be using the insert constraint. The insert constraint essentially will insert a peg into a hole, so it's locked from moving out of it, but it can still rotate within it, and that's huge. So when you're doing the insert constraint, or really any constraint, you have to be very, very careful on which two surfaces you are choosing to be constrained with. So let's do it. I'm going to do it slowly. I'm going to do from the top, constrain, insert. Now, when you hit insert, you have to select two surfaces that you want to be constrained together. So I'm going to hit shift and the middle scroll wheel to kind of see the bottom and kind of envision this. I want the bottom of this to be constrained to the bottom of this. So I'm going to select the bottom of this hole and this right here. Now, is that what I wanted? Not quite, but you can change the direction. And now that's what I wanted. And you can hit apply because I want to do several of these. If you hit OK, it'll save it and then close out of it. So I'll hit OK just to make a point with it. Okay. So now we want to have the drive link get inserted right into it. So constrain, and you can do this one of two ways now. I can either tell the bottom of this to right here, or the top of it to over here. Either one will work. So I'll do the top, and I'll just choose one of these sides. So why did that happen? Something like this, it doesn't look right, correct? The reason it does not look right is because I did the mate constraint. I don't want the mate constraint. I want the insert constraint. So I did that on purpose, just to kind of make a point. That's not how I want to interact. So what I'm doing right now is I'm clicking and holding and then moving it around. That's not what I want. So how do you delete it? Go over here and then delete it. So we're going to do that again and do constrain, and now we're going to do insert. And I'll do this one to that one. Is that what I want? Watch what happens if I hit OK. Now, you are only able to rotate this. And even though that looks close, it's actually not what I want, right? I want that kind of pushed down. So we're going to delete that. And I'm going to do it one more time, and I'm going to do it right, the Goldilocks way. And I'll say I'll do the top to the top or the bottom to the bottom. It doesn't matter. And if it's not the right direction, hit the align to give it the other direction. And watch what it does. I could only rotate it in this way. Now we're going to have a 10 peg to the center link, center to the rocker link, and then back. I'm going to try and do that in 3 minutes, and then in the next video we'll continue with this. So I'm going to do constrain, insert, and the peg one, the 10 one is this color. So I'm going to do bottom to, gotta make sure you're clicking where you need to. And if it's not the right direction, hit this, and then hit apply. And then I'm going to do the center link. I forget which color the center link was. So I'm going to hit escape and then click this, and that's the rocker. So yellow is the center. The top to the top. I always guess wrong. It doesn't matter though. Other direction, make sure that it's flush with the top and the bottom. That's how you know you did it right. And I'm going to hit OK just to kind of spot check it. And now if you click it, look at the way it's interacting. And this is only working because this piece right here is grounded. And everything's moving around it. Okay, let's continue. Apply. Notice how right here, it can ignore physics. So like these are right now occupying the same space. In Inventor, it has no problem with that. In real world, we know that's not true. So just do opposite. And now make sure you note which direction it's going. Like it goes up, up, down, here. So if you do this one on top of it, it won't connect in the end. So make sure that you do the drive link above the web plate, the center above the drive, and then the rocker below. And then from here to here. And then you can do the bottom even, right? Okay. And if you did it correct, your part will work. Common things to troubleshoot if it does not work is make sure that you did everything in the right way. Like it should kind of look like this at the cross section. It goes, again, it goes up, up, down. And here is your finished assembly. So you can now see that it has to move in only these directions because that's how we constrained it. So these are now locked in here, but they are free to rotate, just like you would imagine in the real world that working. Okay, congrats guys. You just finished your first assembly if you have what I have right here.